Hello everyone, in this video we present Semantic Palette, a method for guiding scene generation with class proportions. This work will be presented at CVPR this year. In the context of GAN-based generation of complex natural images, methods relying on semantic layouts have shown improved quality of synthesis by putting some constraints over the content of images. These layouts offers a refined control over the synthesis process, but are difficult to obtain manually. In this work, we introduce Semantic Palette, a layout synthesis method conditioned on class proportions. This allows to fully automate the creation of layout images pairs while controlling their semantic content. Moreover, we extend our framework to partial editing of layouts, which opens up interesting applications. Let's dig into the method. The overall framework is made of a palette generator to select target distribution of semantic classes, a layout synthesizer to translate this histogram into actual layouts, and an image synthesizer to generate corresponding photorealistic views. We split the training process into 3 steps. A. Learning palettes distribution from real layouts by fitting a Gaussian mixture model. B. Training layout and image synthesis models, first individually and then fine-tune end-to-end. C. Using synthetic data for downstream applications, like data augmentation in the training of a segmentation model. We will now detail our major contribution, which is the layout synthesizer. We base our architecture on ProGAN, which we adapt for controllable layout synthesis. It is a cascade of convolutional subnetworks handling information at multiple scales and trained in a progressive way. At each scale, intermediate features are mapped into soft semantic masks thanks to a custom to-mask operation. We also introduce residual conditional fusion, which transforms intermediate masks produced with semantic assistance back to the intermediate features. This helps the model to better comply with the target proportions. Next, we present the objectives we use to train the model. First comes the adversarial objective, to create realistic layouts. This is the job of the layout discriminator, which plays a minimax game with the generator to encourage plausible semantic arrangements. It is trained with the improved WGAN loss, using soft-ground layouts instead of discrete ones to ease the job of the layout generator. Then comes the conditional objective, to make layouts comply with the target proportions. This is carried out within the to-mask operations. To obtain soft layout masks, intermediate features are first projected so that the number of channels correspond to the number of semantic classes. Then, we normalize each semantic activation mask by applying a channel softmax. After that, each semantic mask is weighted by its corresponding target proportion. We finally apply spatial normalization to obtain the soft layout masks. We refer to this combination of operations as the semantically assisted activation. The conditional training objective has 2 parts: the spread loss to favor an even spatial coverage, and the entropy loss to favor a peaky class distribution at its pixel location. Finally, we extend our framework for partial editing of layouts. In this context, the layout generator takes as input a real layout that we wish to edit. We introduce an extra background class to control the degree of novelty that is expected. And we replace the convolutional residual blocks in our architecture by spade residual blocks to account for the layout input. Here are some quantitative results on urban scene benchmarks. Semantic Palette better captures the distribution of real layouts and images than unconditional layout and scene GANs. Semantic Palette better follows target proportions and produces higher quality layouts than conditional baselines. And partial editing is an efficient data augmentation strategy which results in improved MIOU when training segmentation models. Now, let's have a look at some qualitative results. First, we show semantic interpolations where we go from one target distribution to another. Then, latent interpolations, where the target distribution is fixed and we change the noise input. Next, some visualization of the proposed conditional losses. We also explore applications of partial editing to manipulation of faces. As you can see, we can precisely control individual semantic attributes or a combination of such attributes. Thanks a lot for watching. Please have a look at our paper and do not hesitate to reach out if you have any question.